laptop on, we went ahead, we put the number in, and it gave us, I think we had 12 hours. So we punched in, okay, cylinder number one's got injector 98, cylinder number two's got injector, so on and so forth. Hit enter, got the little hourglass, loading done, complete, log out, fired it up, smooth as silk. I'm like, that ain't right.
Program for each of those programs.
Yeah.
That's crazy.
That's nuts.
I never knew that.
Yeah, I didn't either. At the time, I was like, why is this thing running so bad? And the master instructor comes over, he says, well, you marked which one came out, right? I was like, well, no, they're electronic, doesn't matter. He says, oh yeah, Detroit 8 tons.
Yeah, when we had the 50s, we would swap them, but we didn't have that issue. But I mean, it was only the first cylinder.
Yeah, it's 60. Well, this was early on like DDEC 3, DDEC 4, so they might have changed it. Because the time the 50s rolled down, they were DDEC 5 or 6 at that point. So they may have changed that because who numbers their injectors?
Yeah.
You know, and they got tired of their customer service like, hey, you know, I need to, or you buy new injectors, then you either got to have a guy come out and program it, or you got to call in the 1-800 number, go through a bunch of verification, then they give you a one-time use number to put your new injectors in. Well,
And they charge you.
not this date. Well, they may if it was you, because we were LA Unified.
Yeah.
They said, all right, fine. Here's the one-time use access code. We got it done. But I mean, if I'm an owner operator and I got to put in a set of injectors, I don't have time to be calling Detroit and finding a laptop. That's assuming you have the software. How does the guy do it if he doesn't have the software? He doesn't. He's got to go to Detroit and have them do it, and there's another cost. So they may have got a feedback on it and decided to rewrite the program in the ECM so you didn't have to directly enter the injector numbers. So it was a little strange. But getting back to those gauges, it's extremely important that this deck height be within spec. Now Cummins, it's 0 to 48 thousandths, plus or minus 2. Detroit, it's 5 to 15 thousandths, plus or minus 3. So Detroit's a lot tighter on their protrusion than Cummins is. Should you check it? Oh, absolutely. Will you have any problems with it? I doubt it. If the blocks and it's got its OEM configuration, right, the hole in the counter bore, you probably just throw them in and you're good to go. Now, the thing you should check again is the variance. And you got to clamp the cylinder with the tool, 50 foot-pounds, and then unclamp it and then measure it. So it says right on the sheet, measure unclamp in 4 positions. So it's sitting straight. If it's not sitting straight and you can't get it to sit straight, then the guy screwed your counter bore up. You shim it and it's still doing this. And then you got to go in and have if there's enough room, have your counter bore squared up. Now, can they wear unevenly? Sure. Absolutely. They can, you pull a motor down after a few 100,000 K, that counter bore, when these liners, when this engine's running, it looked tight. You had to drive these seat these with a hammer. But when this thing's fired up, these things are vibrating at a very high frequency. Okay? And that vibration over time is going to wear these bores, and it could wear the counter bore. So,
Yeah, but if you get a machine, that shouldn't be counted for years.
yeah, a machinist who does engines like this will know, oh, he's got an 8.9, approximately a 2013 8.9 liter. He's gonna, if he doesn't know it, he'll know to look up that the counter bore has to be X amount of inches from the top, and the deck height has to be X amount of inches minimum. There is no maximum deck height. There's a minimum, and that's it. So when you take the block in to get the parent bores punched, the counter bore should be punched to maintain that OEM depth. And I would, if it were me, I would measure a counter bore when I go to pick the block up to make sure. Get a depth gauge or whatever, and measure it. And if it's not correct, tell them, hey, you got to put this back on a whatever and punch my counter bore because it's too short. And if it's too short, there's nothing I can do in my shop to get my protrusion within spec. Well, I take it back. You can buy the tool and do it yourself. They do make a tool where you can cut your own counter bore. But
Yeah,
again,
that's expensive.
that tool's not cheap. It's not cheap, and nobody wants to deal with that. You know, if I go to a machine shop, I sure as hell don't want to have to do any hand machining when I get it back to my shop. When I get it back, it should be ready to start assembling. Okay, so that's how those gauges work. Yeah, I almost fell over when I
Didn't realize
called.
they were that expensive.
I called Cummins, Leroy Carr out at Cal Pacific out in Bloomfield. He gave me a part number and said, go on Cummins.
He didn't wanna tell you?
No, he did. Well, right away I knew it was gonna be expensive. So then I got the part number. I called the parts section. I gave the dude the number. He gave me the new superseded number. He says, oh, that's $1,785. I said, well, no, I just need the tool. I got my own gauge. No, we don't sell that gauge. You gotta buy the kit. I was like, oh, jeez, are you kidding me? That's when I decided I was gonna go build a company.
Yeah, we have an old one.
Yeah. There's nothing wrong with, you know, I'll have my machine shop square up the two mating surfaces and then give me a better precision hinge post, and I'll be good to go. But I mean, at $1,700, that's ridiculous. You know, and this one,
Just have the machine shop make a whole bunch of them, and then you can sell them for $5.
what's that?
So go up machine shop, make a bunch of.
Well, no, we have our machine shop.
And you can sell them for.
Yeah, no, I
$500
don't wanna lose my job for that one. But I'll have him square this one up. It's probably pretty square as it is. This part's at a bit of an angle, but that's all right. This part's straight. It's in there straight, the hole's straight. So this is a true sled gauge. And, you know, for what I did for it, I'd like to take it up against Cummins and just see how accurate it is. I imagine
It
it'd
looks
be-
almost exactly like that, except it's more of like a welded piece on top.
Yeah, that's what they did. They laid another piece and just welded it.
Yeah.
You know, this one, if you buy this one from Cummins, this base block is about that long.
Yeah.
And
That's about that wide.
Right. And it's got probably a, you know, but for us, it'll do. It'll do. So that's the protrusions, that's, you know, and again, that's important why you have to do it. Like, that's the difference between, you know, paying $8,900 for a rebuild engine. The guy probably didn't measure any of this. He just took the liners, slapped them back in, put a gasket on, put the head on, and then send you down the road. So that might be an engine that has head gasket problems, it might not be. You don't know, and neither does he, right? Whereas, if you take the time to make sure your counter bores are correct, your parent bores are correct, and you measure your protrusions, you get your variances in spec, and you get all the things sunk in where they were, you can pretty much guarantee if the head is flat and it's torqued into place properly, you're not going to have a gasket issue problem. Right? You're not going to have a head gasket issue problem. Because here's the deal. The guy spends 10 grand for a motor, they drop it in, right? And most trucking outfits, small owner operator guys, they don't have 10 grand, so he's paying for this engine over time, probably paying interest. He gets 30,000 miles on it, it pukes a head gasket, he's not going to be a happy guy. He's going to be like, I'm taking it back. You know, I'm still paying on this motor, now I got a head gasket. So the truck's down, he's not making money. And it's down somewhere in, you know, Montula, Montana or some crap. He's got a cooler looking at it, I'll fix it up for you real good. He's like, holy shit, right? So he's making truck payments, he's making engine payments, and he's got a truck sitting somewhere with a blown head gasket. Not gonna be a happy guy. Gets it back, say he takes it to a reputable shop, he says, yeah, the reason your head gasket blown is your liner protrusions aren't correct. Well, how do I fix that? Well, we have to take the pistons out. You're not gonna wanna hear that. You can't really adjust protrusion with the pistons in it, because you can't get the liners out with the pistons and crank in them. So basically, we gotta tear it apart and start all over. Well, I'm still paying on the first rebuild. How many head gaskets you wanna put in it? We can, you know, put some Velcro around it, strap it in there real tight, so the next time it's not so hard, but that's the story. So this is the time to get it done right. We good? All right. Into the classroom. All right. We're going to talk about cooling and lube systems this afternoon. Let's start out with our lubes. This is a typical lube system diagram. We'll go over each component as we go along, but it starts out in the oil pump, goes to the oil pump regulator, goes to the oil pump bypass, thermostat, oil cooler, oil filter, turbocharger. Then it makes its way up to the top of the engine, or the middle of the block, starts lubricating my crankshafts from my main oil galley. Then it goes up to my camshaft. Then it goes up to my rocker arms. This is an older engine, so you had a lower rocker that rode on the camshaft here. You had an upper rocker up here. Now, so it's not a lot of changes in the oil system from engine to engine. They all have their primary components. So we start off with our typical lube pump, and on the Cummins out there, it's right in the front. If I had to change the oil pump on that engine, wouldn't be a bad deal. Pull the timing gear cover off, it's right there. It comes right out. Put a new one in, put it back in. Okay? Now, you remember that little pickup tube we put on, had that small little gasket, those little 8mm bolts that torqued up to something like 68 inch-pounds? Okay, if you want to lose a motor after you've rebuilt it, forget to put that gasket in. You guys drunk a Coke through a straw that's had a hole in it? That's exactly what that pump's going to do. It's going to be trying to draw oil up through that tube when there's no mating gaskets on the block, and guess what? It isn't going to make it. You'll get some oil, but you get more air than oil, and you'll lose that motor. And how soon you lose it? Really quick. You might be out road testing it with the customer, and it might come back on a hook, blowed up. Not good PR for you, right? So that's an important gasket. That's an important spec. The gear pipe pump uses the theory of the reducing space between the gears to force the oil out of the pump. Okay, it's a positive displacement pump. It has an oil pressure regulator that guarantees me a constant range of oil throughout all the RPM ranges. I don't want my oil pressure to be dependent on how fast my engine's spinning, because at idle I'd have no oil pressure. Okay, as it is, some of these engines are making, what, 15 pounds at idle? 22 pounds at idle, 17? Okay. I got an oil pressure regulator that if my oil pressure gets too high, it's going to open up and start dumping oil back into the pan. So the pump is capable of 40 to 60 gallons per minute and anywhere from 150 to 300 pounds per minute. Okay? And it has internal passages that it feeds the block, the main oil rifle, and then the little pass that go off of that. So there's your regulator. And again, it's responsible for constant oil pressure throughout the oil engine operating range. What else will change my oil pressure other than the engine operating range?
Viscosity.
Well, viscosity, but temperature. I start out, fire up my bus at 3:45 in the morning because I got an early run. I'm going to build oil pressure quick because my oil's sitting in there like syrup in the refrigerator. If I don't have some way of regulating that pressure, I'll blow every seal in the motor. So I fire it up in the morning. My oil pressure regulator is going to monitor my pressure with the thick oil between 45 and 55 pounds. And as the oil thins out, I'll still be able to maintain this pressure range because of my regulator. If I didn't have that regulator, as the oil thinned out and the temperature changed, my oil pressures would drop at given RPMs. Make sense? Now, so the type of oil I'm using as well could be important. If I'm using the wrong oil in the engine, then it would affect the oil pressure. If I'm using, what is that stuff you get it right at? Bartle? It's got the yellow can with the checkerboard across the top, the Bartle oil. That's a brand, yeah, that's good quality stuff. That's like $1.29 a quart. Okay. That stuff.
Bardol.
Bardal, is that what it is? B-A-R-D-A-H-L or something? Yeah.
So, yeah.
Yeah. That good quality stuff there. Yeah. But yeah, you could be using the wrong kind of oil in the engine and it would affect it. Because the springs and the settings for the oil pressure regulator are all engineered around a certain type of, a certain quality or a certain type of oil. Okay. Second thing I got in my oil lube system is my filter cooler assembly. So it comes out of the pump into my filter. Now my filter these days is a two-stage filter. Back in the day, we had two separate oil filters spun up on the motor. Who's worked on the old Detroit 92s? I think, didn't the 60s and 50s series have two oil filters as well? Okay. So one was a full flow and the other was a bypass. Okay, so the full flow's job was to get the big chunks out of the oil. 60 micron rating. Anything bigger than 60 microns got hung up in the filter. Anything less got through the filter. Okay, so right out of the oil pump, right into the full flow filter, right into the oil cooler, and then right into the turbocharger for part of it. The second filter, the bypass, was about anywhere from a 15 to 30 micron rated filter, and it would filter out the smaller particles. But about 30% of the oil would be diverted from the pump into that filter and then returned to the pan. With the theory being eventually all the oil is going to make itself through that bypass filter. Today's engines, they have a dual stage single element filter that has the full flow and the bypass element built into it. And so through passages in the filter itself, oil from the pump will go through the full flow, exit the full flow, out to the motor, and then the section of the bypass will go into the bypass, into the full flow, out to the oil cooler, and then out to the turbocharger. Okay? But you notice in there, I've got a thermostat. Why would I have a thermostat in my oil cooler? Let me preface that one with, does oil have an operating temperature range? It does. So, do you think I'd really be needing to flow oil through my cooler after initial startup if I'm leaving, say, Juneau, Alaska in December? Probably don't need to be cooling it much. I may not even have to cool it at all, depending on the temperature and the driving load. You know, if I'm driving through, where my sister lives in Wisconsin, I complained the other day I didn't take my walk out here because it was like 39 degrees. It's cold. So she sends me a selfie of her going for her walk, and it's 9 below. And I'm like, man, I can't really bitch about it being too cold to take my walk, because every time I do, she's gonna, you know, she sent me one the other day, it's 22 below. I'm like, dang. So, you know, it's those kind of weather where, you know, you don't want the oil cold. It's like you take the syrup out of the refrigerator. You know, that's how it is. Now, how well is that going to flow through the motor? Not very. Not very well at all. It's going to put a strain on the oil pump. Okay? Now, what I get a kick out of is I'm going to my walk through the yard, 4:30 in the morning, and I hear a driver start the bus up. Right. I mean, I don't even think the starter's off the ring gear yet, and they got the throttle to the floor.
That's not us, that's mechanics.
So, yeah, because they've got to know how to do that. You got to put it in drive then neutral.
Yeah. No, some of these drivers. Well, somebody.
I know how now.
But, and you ask them, well, why are you doing that? Well, air's up faster. No, it doesn't. That compressor doesn't work any better at 2100 or 2680 than it does at 975. You know? Because that compressor is, once it hits a certain RPM, it's not going to build oil any faster or build air pressure any faster. In fact, oh God, it's about 8 or 9 years ago now. I'm walking through the yard and I hear, and then I walk over to huge oil just pouring out. It's fired a piston to the side of the block. Now, wasn't the driver's fault. I don't think that was from him going wide open throttle on startup. There was probably other issues, but I know that didn't help. Right? Now, would it have failed later on? I don't know. But I just checked my